All I'm going to do in this video is just show you the construction of the tan function. We're not really going to do any work or transformation or any graphing on the tan function. It's just worth it for you to see it. So I've just gone ahead here and computed the tan ratios and written them all out for all of the special triangles that show up between negative pi over 2, so negative 90, and 5 pi over 2, which is 450. So 360, a complete circle, plus another quarter circle. So these are all written down. You can check them by drawing them out on the XY plane, but these are them. And so what I'm going to do is just plot these points, and we'll go from there. Okay, so I've just set up the plot here, not labeling everything, but your 90s, all your 90 degrees, pi over 2s. And so what I've done is plotted everything except for what I've circled on the left where there's actually no point, those DNEs. So I'll talk about those in a second, but hopefully you can kind of match the plotting here. And negative pi over 3, the very leftmost point here is negative 1.73, roughly 1 3/4, negative 1 3/4, negative 1 for the next height, and then 0.56, just a little under negative a half, and then 0, and then positive 0.56, positive 1, positive 1.73. And then we get the same numbers repeating and repeating. So there's a periodicity to tan. We have that full circle happening, just like with sine and cosine. We get repetitions across the circle. So just to look at what's happening at those DNE points a little bit more closely, I'll just draw a picture along the bottom. So if you recall, tan theta in the graph is y over x. And so at negative pi over 2 or pi over 2 or 3 pi over 2 or 5 pi over 2, what we actually have are points on the y-axis, right? So this is 90 degrees, pi over 2. This will be if we go around again. This is 3 pi over 2, 5 pi over 2, negative pi over 2 if we go left. So it's all of these ones that actually end up on the y-axis. And in these cases, what's happening is x is 0 here. So at negative pi over 2, pi over 2, 3 pi over 2, etc., x is 0. So it's very, very similar to what was happening with rational functions. We are dividing by 0. And so what we're actually going to get are vertical asymptotes here. So I'm going to add vertical asymptotes at those DNEs for our graph. All right, so I've drawn my vertical asymptotes for the 4 circle DNEs, and then just kind of using the pattern that's going, I figured, there's probably going to be another one at 7 pi over 2, or we can just use the periodicity. It is 2 pi over, right? So it should have the exact same behavior as we move over. So we'll just get a whole bunch of repetitions there. And so I'm just going to now connect the dots and use the pattern. Hopefully you can see what's going on here. So if I connect these dots, I can see it's going to go down to that vertical asymptote and then up. And it should just do pretty much the exact same thing. Try to actually hit those points. Same thing everywhere. So we get this kind of wacky tan collection of S curves. But you actually might notice something if you're paying attention to period. We can say that there is a period of 2 pi for everything. But for tangent, there's actually a smaller period. Tangent, we call it the fundamental period. It's the smallest possible period you can make, the smallest possible length where you get repetitions. So for tangent, it's actually pi, or 180 degrees. So every 180 degrees, we get the exact same picture again and again. And that's just because if you look at this graph, when we're up across the top, we're in these positives, and then they go negative. And then if we start back over it, it's the same triangles, but then positive and negative for those tan ratios. So you get the repetition just in the top half, bottom half, top half, bottom half. But yeah, so this is what the graph looks like. As you can imagine, it would be pretty horrible to do transformations on something like this. It'll be very, very difficult to see. So I'm not going to really ask you to do much with this. It's just good for you to see, um, just for some stuff that we'll do later on. So just so you can't scream that I never showed you this, but you shouldn't really get any questions related to it. So yeah, there's your tan graph.